Welcome to a brand new episode of the Cleared Send podcast. This is François. I'm here with Rowell. Hey, Rowell, how are you?
Hello. Thanks for listening, everyone.
So we're back for another episode of Back to Basics. In the first episode, we've talked about the evolution of the Wi-Fi standards. In this second episode, we're going to talk about channels and frequency bands.
Mm-hmm.
All right. So we're going to kind of explain which frequency band and which channels we can use in Wi-Fi, and I guess the evolution over the years as well. And the first thing we need to mention is that the channels available for Wi-Fi use, they're usually regulated by the country. So each country may have different rules when it comes to which frequency band you can use for Wi-Fi, and also how much power you can use on these frequency bands. So this is usually regulated by the some agencies related to the government. In the US, you have the FCC. Each country has their own. In Canada, we have something called IZ. And so if you want to know for your country who is regulating the frequency space, then you can go and search out this information. It's usually available in the the government websites, or if you just Google it, you'll find it. I believe there's also a table on Wikipedia where you can find that information.
Yeah, so as we talk about these channels and head over to the YouTube channel to see the reference sheet that we'll have to display all the channels, you may not have all these channels available to you, as Francois said, with the different agencies that regulate. So just be aware of that, but we'll show you all the channels that are defined, that can be used within the standard. But just remember, you got a regulation that you may not be able to use it.
Yes, and the regulation term is important there, because if you don't respect these regulations, you can get in trouble. So the question always becomes, when you're installing an AP, understand where you're installing this AP and make sure that you respect the regulation of that specific place.
And when you are deploying an AP, there is an AP country code that will be attached to that AP. So that's one thing to look at. So if you ever have trouble where you're deploying an AP and it's not, you don't see all the channels for some reason, you may want to check the country code that it's in. And I think as we go into this, just keep that in the back of your mind, and we'll end up showing the reference sheet right here.
Yeah, and we'll start with 2.4. You guys know in Wi-Fi, if you've listened to episode number 1, you should know now that Wi-Fi can be used on 2.4, 5 gigahertz, and 6 gigahertz. Today, we'll start with 2.4 because that's where Wi-Fi started. And in 2.4, here we have on the reference sheet, you'll see the band starts at 2.4 gigahertz. It ends at 2.485. And within this spectrum, which is about 80 megahertz, 85 megahertz of spectrum, then we have the ability to use up to 3 Wi-Fi channels. You'll see that we have different channel numbers. Each channel number is separated by 5 megahertz. But remember, Wi-Fi channels are 20 or 22 megahertz wide in 2.4. So if we don't want to have overlapping channels, then we are restricted in the number of channels we can use. So you can see here on this diagram, we usually stick to the first non-overlapping channels, which would be 1, 6, and 11. You've probably heard this, 1, 6, 11, if you've done Wi-Fi for a while. And these are the 3 channels that we usually use on 2.4.
Yeah, and we'd say non-overlapping channels because in future episodes we'll talk about co-channel interference or contention, and you just want to have different non-overlapping channels in 2.4 to try to avoid that contention. Now, with only three available non-overlapping channels, that becomes a challenge once you get over 3 APs being deployed, and then having to also contend for airtime with the surrounding access points from your neighbors. And so that's why 2.4, we always recommend going to 5 at this point, because once we show you that reference sheet, we'll show you why.
Yeah. So usually in the real world, like Rowell was saying, is you will have your APs use channel 1, 6, 11, but usually you will have multiple APs on channel 1, multiple APs on channel 6, and multiple APs on channel 11.
Yeah, it's unavoidable.
Yes.
And also some vendors allow you to channel bond on 2.4. Not something we recommend doing. You can probably do it at home, but not in the enterprise space or warehouses.
Yeah. Something else you will notice here on the reference sheet is that we've detailed a 22 megahertz channel plan, but also a 20 megahertz channel plan. And that's because if you remember from the previous episode, with OFDM, we use 20 megahertz channels. With previous technologies, 802.11 and 802.11b, we use 22 megahertz. So depending on the technology, you'll use more or less space on the spectrum. But also in some countries, you can have up to 13 channels available in the 2.4 spectrum. So you could potentially, in theory, you could have enough room to actually use 4 channels on 2.4, 1, 5, 9, 13. And this is something that you might see out there in the wild, especially in Europe, where they have 13 channels available. The catch with this, or the little caveat that you have to keep in mind, is that if you use 1, 5, 9, 13, but your neighbors use 1, 6, 11, then you're going to start to have a lot of overlapping between your APs, for instance, on channel 5 and your neighbor's APs on channel 6. So if you want to do 1, 5, 9, 13, you need first to make sure that you only use OFDM. Secondly, you need to make sure that you don't have any neighbors around using the 1, 6, 11 in schema. And that's why in most of the case, even in Europe, people kind of stick to 1, 6, 11. It's kind of like a common thing to do.
Yeah. Yeah, that's good information. So that's 2.4.
That's 2.4, the smallest of the 3 bands. So let's move up to 5 gigahertz. And 5 gigahertz, we have a lot more spectrum available. We have roughly 500 megahertz of spectrum that we can use for Wi-Fi use. Once again, this will change country by country. I believe what you have in front of you is the US channels. And here, what they did change in 5 gigahertz is the fact that instead of having 5 megahertz between each channels, now we have 20 megahertz between each channel. So we don't have that channel overlap thing that we had in 2.4. And you can see that we have, I believe, 25 channels available, 20 megahertz channels available. And on the diagram, you can also see how you can bond some of these channels. So how you can come up with 40s, 80s, and 160 megahertz wide channels.
A lot more flexibility here in terms of channel planning, the number of APs you can deploy without having to introduce overlap. But just remember, when you're using the wider channels, as you're channel bonding and you have neighboring access points, you will still be overlapping on the smaller 20 megahertz wide channels. So if you're thinking you can get much more higher throughput because you're using 80, but then you're not seeing it, I would look to identifying what neighbors are around, and maybe they're on the same channels as you, and that's why you're seeing lower throughput. But this is primarily where we've lived in the last, I don't know, how many years has it been, where we've been recommending 5 gigahertz, smaller channel widths, right? 20 megahertz channels. And I still stick in the 20 megahertz wide channels for 5 gigahertz. But in many of the environments I'm in, it's a big deployment, especially with other neighbors, like in cities like San Francisco, where you can hear so many APs.
Yeah, it's interesting. Even though, and here on this diagram, you can clearly see the impact of using larger channel width. The first impact is that you will have less channels available to you. So like Rowell said, if you have a lot of APs to deploy and you have less channel, you're going to have to reuse these channels more often. And you have, you're going to introduce co-channel interference if you do. So if you have to install a lot of APs, it's better to stick to 20 megahertz wide channels, because you won't have to reuse your channels as often.
Yeah, I would even say 40 megahertz wide channels is a good start to see if you can pull that off. But 20 megahertz for better stability and performance, like that's where we kind of stick around for many deployments. And in the very beginning, when we were rolling out 5 gigahertz, most devices were supporting like up to 40 megahertz wide channels. There weren't too many even supporting 160 yet. And that's why we'll move over to the next frequency when when
Yeah, when this one will
all
be
these newer
saturated.
devices. Yeah.
This there's one thing also with 5 gigahertz that I think we have to mention, and maybe you'll see it like in this diagram. The 5 gigahertz frequency band is actually divided into sub bands. So here we have the US naming, but you have Uni 1, Uni 2, Uni 2 extended, Uni 3. And you can also see we have a space between Uni 2 and Uni 2 extended. You could ask yourself, okay, why do we have space here?
Yeah, what
and
happened
that's
to channels 65 through 99?
Yeah, what happened to this channel? And that's the reason why we have this segmentation is because before 5 gigahertz was available for unlicensed use and Wi-Fi, these spectrum were actually allocated to different applications or different people. And when when the agencies like the FCC decided to make it available for everyone, then they kind of had to keep the same segmentation because they might apply different rules on how you can use those frequency space based on who is the incumbent. And that's why you'll see in 5 gigahertz, we won't talk too much about it here, but you may hear something called DFS. We've done some episode on it. You guys can search for it. But on some of these frequency band, you need to extend it. You will have to comply with the DFS mechanism. The APs will have to comply with the support DFS. And this is something that's mandatory because, on these frequency bands, Wi-Fi is not alone. And you have other technologies that have been using the frequency for a longer time, and therefore Wi-Fi doesn't have the priority, and we need some mechanism to make sure that Wi-Fi is not impacting the incumbent population.
Yeah, exactly. We'll call them incumbents because that's what we'll even talk about with 6 gigahertz. But the incumbents have that first priority over these frequencies on Uni 2 and Uni 2 extended. And what you'll see are some devices that won't even support Uni 2 or Uni 2 extended, because you need certification to even use those, right? And so some devices just support Uni 1 and Uni 3. The other thing to think about with these channels is what I've seen in the wild are some devices that support some of these channels. Like for sure Uni 1 and Uni 3 these devices support, but some devices will support Uni 1 and Uni 2, skip Uni 2 extended, and then go to Uni 3. And it's just important to read spec sheets, test out these devices, try to identify what some of these devices support when they associate to an AP. But those incumbents on Uni 2 and Uni 2 extended, that's like what François said, DFS. There's weather radar and aircraft radar, where in your infrastructure you might get something called DFS detected. And so what that mechanism François is talking about is the AP will tell all the clients, hey, we got to get off this channel, let's say a channel 100, and there'll be this channel announcement that says, hey, go to channel, for example, 36, and all basically all the devices and AP shift there because they can't talk on that frequency anymore. It's very interesting in how it works.
This is where you'll see the most differences in between countries is usually in these channels. Like some countries, some channels will not be available at all. In some other countries, it will with DFS. So you'll see differences in between countries on how you can use the channels. And on 5 gigahertz, also you'll see differences in between countries on how much power you can use on these frequency bands. So that might impact your maximum transmit power and your design in some scenarios.
Yeah, and especially if you can't use Uni 2 extended and you're trying to use 160 megahertz wide channels, you've essentially got one channel you can use.
Yeah.
But
okay, so that's that thing. We can move to 6 gigahertz, which is the new frequency space now available. Not everywhere, but in a lot of countries nowadays. And 6 gigahertz, it's even a larger amount of spectrum. I think it's about 1200 megahertz.
Yeah.
So we call it, fun fact actually, we call it 6 gigahertz, but it starts at 5.9 and it
Yeah.
ends at 7.1. So yeah, so you'll see it's a quite a large amount of spectrum. We have different channels. Each channels are separated by 20 megahertz, so it's very similar to 5 gigahertz in that regard. What's different is the channel numbering,
Yeah.
because with 2.4 and 5 gigahertz, we had kind of a continuous channel numbering. So we didn't have the same number of channels on 2.4 versus 5 gigahertz. With 6 gigahertz, they couldn't really continue that numbering because they were limited in how many bits they could use to identify the channel number in the frame. And therefore, they had to restart at 0 or at 1. So the first channel is called channel 1.
Yeah,
which also
not to be
exists.
confused.
Not to be confusing at all, because now we have channel 1 on 2.4, but also on 6 gigahertz. And another example that I always give is we also have channel 149 on 5 gigahertz, but now we have it on 6 gigahertz.
Yeah. Same with 165. Yeah, it's confused me a couple of times whenever I look at 6 gigahertz and I'm going, I'm on channel 149, but then I'll look at 5 gigahertz. I'm like, I'm broadcasting on both 149 on 5 and 6. So which one am I on?
Yeah. Yeah. So anyway, they had to do this because we have a lot of channels. It starts at 1, it goes up to 233, and we have, I believe it's 59 20 megahertz wide channels.
Yeah,
plenty of channels. And you can also see that we have the sub bands that we were referencing in 5 gigahertz. So we have Uni 5, Uni 6, Uni 7, Uni 8. And depending on which country you're in, you may not have access to everything. In the US, Canada, it's pretty good. We have access to everything, at least for the low power indoor. For Europe, they only have access to Uni 5, which is pretty much like the first 40% of the frequency band. But the biggest benefit of 6 gigahertz is the fact that we could start using larger channels because we have a lot more spectrum. So
just
we actually
80 megahertz, right? Like we were just talking about 80 megahertz and 5 gigahertz. Here, let me go back real quick. 80 megahertz and 160 megahertz in the 5 gigahertz spectrum. That's how many channels we have for non-overlapping. But when we go to 6 gigahertz, obviously, I think 80 will probably be a good starting point for new deployments. Even for some, might even do 160.
Yeah, I think so. On 5 gigahertz, I think you had like 5 or 6 80 megahertz wide channels. 1, 2, 3, 4, 5, 6. And on 6 gigahertz, we have 14. So we have a lot more. And, for an environment, for an office environment or something simple, normal density, I think it's totally viable to do 80 megahertz on 6 gigahertz. And that's going to boost the data rate. Like if you're going from a 20 megahertz wide channel on 5 gigahertz to 80 on 6 gigahertz, you're gonna quadruple even more your data rate. So
and with how clean 6 gigahertz looks today, I don't see why not. Like there's not much going on 6 gigahertz at this time. I think even here where I live, I've seen one 6 gigahertz network, but it was very, very weak. And so someone's already got 6 gigahertz deployed around here. They're using, I think, 160 megahertz wide channels. But
why not?
Hey, why not? There's no one on it. Until I start turning on all my test devices, and then they'll start wondering what's going on. But this allows us to really get that very high throughput that if you listen to our previous episode, this is how we're going to achieve that.
Yeah, and 160 megahertz might be viable in some environment because we have 1, 2, 3, 4, 5, 6, 7. Like in my house, for instance, I have 3 APs. I use 160. Why not? There's no one there on 6 gigahertz.
Very small offices can use it. Smaller environments. It's going to be something we'll see pretty soon, I think. I wouldn't even be surprised if I saw a couple of 320 megahertz wide channel widths. And we'll also see newer use cases. This is where I might start seeing some mesh being thrown around, because maybe they'll use 6 gigahertz as a backhaul and make use of the wider channel width.
Yeah, so that's very exciting. The spectrum is it's huge, and there's also something we haven't talked about here is the incumbent, because 6 gigahertz is just like 5 gigahertz. In some of these bands, we have some incumbents, and the way they decided to deal with that is they created classification for devices. So they have a classification of device called low power indoor that we can use without any restrictions on all of these channels, depending on the country you're in. And then they created another, but so the low power indoor you can use everywhere, but the limitation is you can only use it indoor with a limited amount of transmit power.
Yes.
And if we want to use more power, if you want to start deploying outdoor, if you want to use external antennas in some countries, then you will have to use a different classification of devices called standard power. And for standard power to work, the AP will have to talk to something called an AFC provider to make sure that it provides its GPS location. And then the AFC provider will come back and say if it can use that channel and if it has any power limitation. And so that, that we will have kind of a centralized database that will make sure that the new Wi-Fi, 6 GHz Wi-Fi deployments do not interfere with the existing incumbents.
Yeah, and it's not listed there in the reference sheet, but with the low power indoor and standard power, low power indoor has been out now for a while, but the standard power is very much new, because the FCC just, I don't know what, a month ago just said, hey, we can do standard power. And so now we're waiting for vendors to get their APs certified to be used to use standard power. And when François mentioned the use of AFC, all that really means is when you've got your AP outdoors, it has to provide its location to the AFC operator. And the AFC operator knows what frequencies are being used in the area by the incumbents. And so the AFC operator will send a list of channels that the standard power AP can use depending on its GPS location. So all of that should be built in to the Wi-Fi system you're using. I don't think you're going to need to select an AFC operator. I hope not. And that'll just complicate things. But you cannot take a low power indoor AP and put it outdoors. It's not intended per regulation.
Most of the, re-recording this is in April 2024. Most of the new outdoor APs, they kind of support standard power, but it's not like enabled yet because of the AFC piece. But as soon as the AFC piece will be there, then you'll be able to use it. And so the hardware
happen
is not
either probably next month in May 2024. We might see one available to use.
Awesome.
But yeah.
Anything else we should add, Rowell, on the channels?
No, I think it's pretty simple. You can head over to the clear2send.net website to download these PDFs if you want to keep the reference sheet for yourself on the channels. You can use it for studying for your CWNA, or just to keep a reminder of what 6 gigahertz channels you could use. Because I know I have to reference something for 6 gigahertz channels and how many channels are available given a channel width. But we want to encourage you guys to leave a comment. Are you using 6 gigahertz? Are you testing it? I'm kind of curious to know, but let us know what your thoughts are, and be sure to subscribe to us on YouTube so you can see all the new episodes.
And tell your friends about it too. And so stay tuned for the next episode. This will be episode 3. We'll talk about Wi-Fi security and encryption. So stay tuned for that. We'll be back soon. Thank you, guys.
All right, thanks, guys. Bye.
Cheers. Bye-bye.